Two similar cones have volumes in the ratio of 8 to 27. Calculate the ratio of their heights. Now here we have a useful table. And this table tells us that we have the length, and then we have the scale factor. So we have the length scale factor, and we have area, and area is going to be the scale factor squared. And then we have volume, and volume is going to be equal to the scale factor raised to the power of 3. Now, what does this mean? Well, this table is very useful because it's telling us that if we have the scale factor, right? If we have the scale factor, the length scale factor, and we need to figure out what is the area scale factor, all we need to do is take our scale factor and raise it to the power of 2. And then we're going to get the area scale factor. Moreover, this table tells us that if we have the length scale factor, all we need to do is take the length scale factor and raise it to the power of 3, and then we'll get the volume scale factor. Now, here, the question wants us to figure out what is the ratio of their heights, all right? And so, I know this table has a length in it, but we can also use the word height, all right? The same thing is true for the height scale factor, all right? So, if we have the height scale factor, and we want to figure out what is the volume scale factor, all we need to do is raise it to the power of 3. And if we have the height scale factor and we want to find out the area scale factor, all we need to do is raise it to the power of 2. Now, so with that being said, how is the information that they give us inside this question useful? Well, it tells us that these two cones, these two similar cones have volumes in the ratio 8 to 27. And so they're giving us the volume scale factor. And so if we want to figure out, if we are given the volume scale factor, and we want to figure out what is the length scale factor, we're not going to raise it to the power of 3. We're going to take the cube root, all right? The cube root. So again, if we have the length or height scale factor, right? If we have the height scale factor, and we want to move from the height scale factor to the volume scale factor, well, we raise it to the power of 3. But if we have the volume scale factor, right, and we want to move from the volume scale factor to the length or height scale factor, then we have to take the cube root, all right? And so that's what we'll do. We have that the volume scale factor is 27 over 8. In order to find the length or the height scale factor, we have to take the cube root of both of these numbers, the cube root of 27 and the cube root of 8, because we're moving from the volume to the length. In that case, or the volume to the height, and in that case, we have to take the cube root. But if we're moving from the length scale factor to the volume scale factor, then we raise it to the power of 3. And so what is the cube root of 27? The cube root of 27 is 3, because 3 times 3 times 3 is 27. And the cube root of 8 is 2, because 2 times 2 times 2 is 8. And so what does that mean? That means that the ratio of their heights is going to be 3. I'm sorry, it's the ratio of their heights is going to be 2 to 3. Why 2 to 3? 2 to 3 because we use the volume scale factor, and that's able to help us what? To get the length or the height scale factor. And then we can determine the ratio of their heights, which is 2 to 3. Now let's move on to, and we get the 2 to 3 because of this particular fraction. Now let's move on to the next question. They want us to calculate the ratio of their surface areas. Now we're going to use the same chart, right? We know that if we have the length or the height scale factor, and we want to move from the length or height scale factor to the area scale factor, all we need to do is we need to raise the scale factor, the length scale factor, to the power of 2, okay? So again, if we have the length or height scale factor, and we want to figure what is the area scale factor, all we need to do is take the scale factor and raise it to the power of 2. With that in mind, let's figure out the ratio of their surface areas. Now, we know that the length scale factor from the previous question is 3 over 2. In order to figure out what is the area scale factor, we're going to square it, right? So we say 3 over 2 squared. And 3 over 2 squared means that we're going to say 3 squared and 2 squared. And 3 squared is 9 and 2 squared is 4. And so if you want to figure out the ratio of their surface areas, we're going to say 4 to 9. And 4 to 9 because the bottom here is 4 and 9 here because the top is 9. And so the ratio of their surface areas is 4 to 9. And that's the answer to this particular question.